everyone. I am Minakshi Chauhan, working as an assistant professor, IT department, KIET group of institution, Ghaziabad. In this lecture, I will be discussing about instruction format. In this lecture, I will be discussing about what is an instruction and what are the different formats of an instruction. So let's get started. So what is an instruction? An instruction is a command, or we can say a binary code, which is given to the microprocessor to perform a given task. So it instructs a microprocessor to perform something. The task will be performed on some data. Instruction has two parts, mainly two parts. One is opcode and second is operand. Opcode defines the operation which is going to be performed, and an operand defines the data on which the operation will be performed. Operand, or we can say data, can be specified in various ways. It may include 8-bit data or 16-bit data. Data may be stored in internal register of the processor, or data may be fetched from the memory location, or data may be as 8-bit or 16-bit address. Sometimes operand is implicit in the opcode of the instruction. So mainly instruction performs some operation on some data. Now, what are the different instruction formats? So according to the word size, in 8085, we can classify the instruction set into three categories. One word or one byte instruction. Second, 2-word or 2-byte instructions. Next, 3-word or 3-byte instructions. 8085 microprocessor has 8-bit word size. So word size is equals to byte size. So we can say that it is a word or byte equal. So we can refer as 1 word or 1 byte, 2 word or 2 byte, 3 word or 3 byte instruction formats. Now we will see each instruction format one by one. So first, 1 byte instruction format. As its name suggests that the instruction has only 1 byte. So 1 byte includes opcode and operand in the same byte. Opcode and operand can be specified with the help of only 8 bits. So these type of instruction will be having 1 byte instruction format. In these type of instructions, operands are internal register of the processor, or maybe some implicit operands coded in instruction. So for example, we have move CA command. This command is 1 byte command. The binary code for this command is like this. And we can specify these binary bits into hexadecimal notation. So we can say that this instruction has 4FH hexacode. So 4F is representing move CA command, which is moving the content of register A into register C. Next example is add the content of register B to the content of accumulator. So here we can take another example as add B. Here only one operand is specified. That means the other operand is implicit, and this operand is stored in accumulator. Invert or complement each bit in accumulator. CMA command. So CMA command, no operand is being specified here. It has only opcode. So opcode is defined by 8-bit. That's why it is 1-byte instruction. And now this binary code can be converted into hexadecimal, and this is the hex code for this instruction. So these are the example for 1-byte instruction format. The main property is that these instruction is specified by only 1 byte. So here in first type of instruction format, both operands are in internal register of processor, and in second one operand is in internal register of the processor or general purpose register of the processor, and the other operand is in accumulator. And in the next example, here the operand is implicit. So these are the example of 1-byte instruction format. Next, 2-byte instruction format. Here the instruction will be specified by 2 bytes. In 2-byte instruction, first byte will specify a code, operation code, and the second byte will specify the operand. Here the source operand is a data byte immediately following the opcode. So first byte is opcode and second byte following byte is operand. Such type of instruction will take 2 memory location, 1 location for each byte. So some example are here. One is MVI A32H. So MVI is move immediate. So this command is having 2 bytes. First byte is specifying the code, and the code is opcode move MVI move immediate. Immediate means it is moving some immediate value into accumulator. Immediate value, the value will be specified here. So the first byte is representing the code, opcode, and the second byte is representing the operand. In this case, the value is, for example, it is 32. Here you can specify any value. So this is the immediate value, where the value is itself present in instruction. So next example is load 8-bit data byte in register B. So move MVI B F2. So here immediate value F2 in hexadecimal is being moved to register B. So first byte is representing code and second byte is representing the operand. Now next is 3-byte instruction format. Here in 3-byte instruction, the first byte will specify the opcode as same as before, and the following 2 bytes specify 16-bit address. So 16-bit address will take 2 bytes. Here note that the second byte is lower order address and the third byte is higher order address. So address will be written like first we will take the lower address bits and then we will take the higher order address bits. This instruction will require 3 memory locations to be stored in the memory. For example, here LDA 2050. This command specifies that load this address to accumulator. So LDA is load to accumulator, and here we specify the 16-bit address. So this command is 3-byte instruction, which takes 3 bytes to get stored in memory, where first byte will specify the opcode. So LDA, load to accumulator. Next, second byte will specify the lower bit of the address, and lower order bits of the address are 50. So next byte will represent 50, and next higher order address bits will be specified by third byte. Here we have taken this example. You can take any other address too. Here in another example we have jump 2085. So here we are taking a jump branching condition. It specifies that the control will jump to the given address or a specified address. So transfer the program sequence to memory location this. It means branching the control of the execution to the specified address. So this command will be represented by 3 bytes. First byte will represent the opcode jump. Second byte will represent the lower bit address of lower order bits of the address. These are 85. And now third byte will specify the higher order address bits. These are that is 20. So in this way, we 3-byte instruction will take 3 byte. So we will require 3 bytes or we can say 3 memory location to store this type of instructions. So here we discussed about the instruction formats. One is 1-byte instruction format, second 2-byte instruction format, and then 3-byte instruction format. And the content of this lecture was taken from Microprocessor Architecture Programming and Applications with 8085, written by Sir Ramesh S. Goenka. Thank you. Happy learning.